Welcome Math 10C students. In today's lesson 7.5, we're going to be looking at a new strategy to solve for a system of linear equations. So if you remember from the previous videos, we solved them given some values algebraically, we solved them graphically, and we also solved them using something called substitution method. So for today, we're going to be using something called an elimination strategy in order to solve a linear system. So I'm going to go through how we would go about doing this, elimination method to solve for our system of linear equations to find that solution. So if we take a look at this, they have graphically solved this system of linear equations, So they've graphed both of them and then they found the intersect of the line. Remember, the intersect of the two graphs tells us the solution. But another way we could do this is through something called elimination method. Okay, so how they've shown us kind of the pre-explanation is they've taken the two equations and they've added them together to make a new equation. And then they've graphed that third equation right here, so that 3x plus 4y equals 10. So we can see from the graph of the new equation, when we mark it on the same grid, that it also passes through that 2x equals 2, y equals 1 point. So we can use that property to solve a linear system. So in order to solve this first linear system, we can use that elimination method, and we can do that to eliminate a variable. So in order to use this elimination method, there has to be something present or we have to change the equations to make something present. So in this case, we need to add the equations together to eliminate one variable. So if we were to add these two equations together, you'll notice that -2 and +2 are the coefficients of y. So in order to use this elimination method, we need two coefficients that are the same number but opposite operations. So if we were to add these two together, which I'll do right now, we'd end up with 9x, a +2y and a -2y gives you 0y equals, and if we add those two values together, we get 36. So from there, we can say 9x equals 36, divide both sides by 9, x is equal to 4. So from using this elimination method, we can solve for our x value. Once we have one of the values, we can substitute that number into either of the equations to solve for the other. So I'll just pop this into equation number 1 to solve for y. So then we end up with 4 times 4, minus 2y equals 10. So that's 16 minus 2y equals 10. -2y equals 10 minus 16. -2y equals -6. And then divide both sides by -2 to get y equals 3. Okay, and then the last thing you could do is verify these by popping both of these numbers into the equations and making sure that it does in fact work. So verifying it. So you can see here on the top of the next page, they've popped both of those numbers in. So x equals 4, y equals 3 into the equation to make sure that left side equals right side in both of these cases. And they do, so that is our solution of the linear system. So I encourage you to pause the video now and try the check question on page 408. I'm going to go ahead and solve that for you. So you can pause now and then I will solve it for you right now. So we're given, again, a system of linear equations. We will note here that the x value, this is a +2, that's a -2. So the coefficients of x in both of the equations are opposite integers. So we are able to use elimination method for this. So we're going to add the two equations together and that should get rid of x. 2x plus a -2x equals 0. Then we have negative 8y plus 11y, plus 3y, which gives us negative 5y. And then we have negative 18 plus 8, which gives us 10. If we divide both sides by negative 5, we end up with y equals 2. So now that we know that y equals 2, we can find the value of x by substituting that in. It doesn't matter which of the two equations you use. Here they suggested we do it in equation number 2, so we will. Negative 2x plus 3 times 2. Negative 2x plus 3 times 2 is 6, gives us 8. Negative 2x equals 8 minus 6. Negative 2x equals 2. And then if we divide both sides by negative 2, we end up with negative 1. So our solution is x equals negative 1, y equals 2. In order to check our work, we can verify this by substituting those two values into my original two equations. So remember, negative 1 and 2 are the values we're going to try out. So on the left side, 2 times negative 1 minus 8 times positive 2 equals negative 18. 2 times negative 1 is negative 2 minus 16. We end up with negative 18, and that is equal to the right side. Let's try the other equation, negative 2 times negative 1 plus 3 times positive 2 equals 8. Negative 1 times negative 2 is 2. 3 times 2 is 6. 2 plus 6 is 8. Left side is equal to right side in both cases. So our solution is negative 1 and 2. Okay, so again, that was using elimination method. Now, this worked in both of these instances because the coefficients were opposite integers, meaning one of them was a positive number, one of them was a negative number of the same number. Now, we can still use this elimination method, but sometimes we have to multiply either one or both of our equations by a number before we're able to eliminate a variable by adding it together. Okay, so sometimes we're going to have to use multiplication in order to use this elimination method. So let's take a look at the next example here. We're given these two equations. Now, you will notice that there are no negative or opposite integers because we have a positive 4 and a positive 3. Those are not opposites. And then we have a negative 2 and a positive 1. Those are not opposites either. So what I'm going to suggest, and again, you could do this in a number of different ways, I'm going to suggest we're going to look at the y terms because it'll be a little bit less that we have to do. If we were to look at the x's, we would have to multiply both of them by their lowest common multiple, but instead we'll look at the y terms. So this is a negative 2. We could make this one a positive 2 if we multiplied the entire equation by 2. So let me show you what that would look like. 2 times 3x plus y equals negative 6. So I'm going to multiply 2 by that entire equation in order to get a new equation that I can use elimination for. So 2 times 3x is 6x. 2 times a positive y is positive 2y. And 2 times negative 6 is negative 12. So now I can use this version of the equation with my original for equation number 1 to solve using the elimination method. So now I can add those two together. 4x plus 6x is 10x. Negative 2y plus a positive 2y is 0. And 2 plus negative 12 is negative 10. I can divide both sides by 10 to get x equals negative 1. Now that I have my x value, I can input that into either of my equations to solve for y. So I'll just use equation number 1. That means I have 4 times negative 1 minus 2y equals 2. Negative 4 minus 2y equals 2. Move the negative 4 to the other side. Negative 2y equals 2 plus 4, because it's a negative 4 here, so in order to get rid of the negative, I add that to both sides. To both sides. Then I end up with 2y equals 6. Divide both sides by negative 2, and I end up with y equals negative 3. So those are my two answers. Of course, I can check my work by verifying. Remember, to verify, all I have to do is pop those two terms into both equations and make sure left side equals right side. I kind of ran out of room on this piece of paper, so I'll just show you here on the bottom. They've substituted both of those values in, the negative 1 and the negative 3 that we came up with. And you'll notice for both of these, left side equals right side, left side equals right side. So that is the answer to my system of linear equations. So again, I can use this elimination method by multiplying either one or both of the equations so that they have opposite integers. So you have now the opportunity to try one of these questions on your own. This question is on page 410. So I suggest that you pause the video now. Try this question on page 410. Now, this one, they've encouraged you which terms to look at. They've said, let's use these two terms, the y terms. But of course, you could use the x terms if you wanted to as well. So please pause the video now, and I'm going to go ahead and solve this equation for you. So we have these two linear equations here. We can use elimination. You'll notice that none of the coefficients of like terms are opposite integers. So the x's are not opposite integers, and the y's aren't either. But you'll notice that this is a positive y and this is a negative y. So if I multiply this entire equation by a positive 10, then this will end up as a positive 10y, and this will end up as a negative 10y. So that's what we're going to do here. So we're going to make the coefficients opposite integers. That means I need to multiply equation number 2 by 10. So let's do that. By 10, that means I have 10 times 2x plus y equals 3. So 10 times 2x is 20x. 10 times a positive y is 10y. And 10 times 3 is 30. So now I can add these two equations. This is my new equation. Add them together. So that original top one I had, and 20x plus 10y equals 30. So we'll add those together. I end up with 23x. The two y's cancel each other out, equals 30. Oh, sorry, 46. 46. I can divide each side by 23, and I end up with x equals 2. So I can find the y value by substituting x equals 2, and here they've suggested we do it in that original equation number. So 2 times 2 plus y equals 3. That means 4 plus y equals 3. Y equals 3 minus 4. So y is equal to negative 1. Let's see if those are in fact my numbers I want. Is this the solution? Again, how do I do that? I verify by substituting both of these terms into both of the equations to make sure that left side equals right side. So I have 3 times 2 minus 10 times negative 1. That should equal 16. So that's 6 minus, so 10 minus, sorry, 10 times negative 1 is a positive. So I end up with 16 equal to 16, yep. And on the right side, I have 2 times 2 plus negative 1 should equal 3. 2 times 2 is 4. 4 minus 1 is equal to 3. Okay, so you'll notice that my left side and right side are equal. That means that these are, in fact, the numbers or the solution to my linear system. All right, there is one more example here that I'd like to go through with you. For this one, I'd like to do this one on some separate paper. The reason being is just so you can have that practice of modeling this situation first. And then once you've done the modeling, you can check your answers. So they'd like us to create a linear system to model this situation. It says Ethan and Ava sold flower bulbs for a school fundraiser. Ava sold 5 bags of tulip bulbs, 2 bags of daffodil bulbs. She raised $80. So let's start by coming up with an equation for that. I'm going to use T for tulips and D for daffodils. So she has 5 tulips plus 2 daffodils, and those together equal $80. For Ethan's, we're going to use the same variables. He has 1 bag of tulips plus 4 bags of daffodils, and that equals $70. Okay, so now we have 2 linear equations. We have a system of linear equations, and they want us to solve the problem. So they want to know the cost of each type of bulb. So how much are the tulips? How much are the daffodils? So what we can do is, again, we can use that elimination method that we had been using previously. You might also look at this question and say, hey, look at that t, that's by itself and there's no variable here. So technically you could also rearrange this to use substitution method, but remember they've asked us to use elimination. So we're going to go through the process of how we would use elimination method. Now I would probably do the editing to the t's, because if I do something to the d's, I might have to change both equations. So let's focus on the t's. This is a positive 5. That means I want to make this one a negative 5. So I can multiply that entire second equation. We'll call this number 1, number 2. I can multiply the second entire equation by negative 5 to make those opposite integers. So let's try it. Negative 5 times t plus 4d equals 70. I end up with negative 5t minus 20d equals negative 350. Okay, so now I can use elimination method using this new equation. We'll call it number 3. So we'll add number 1 and number 3 together. 5t plus 2d equals 80. And I'm going to add negative 5t minus 20d equals negative 350. So now my t's will cancel out. I end up with negative 18d and 350 minus 80 is negative 270. Now if I divide both sides by negative 18, I get d is equal to 15. Now that I have my value of d, I can go ahead and solve for t. I'm going to just input it into equation number 2 because that one was a little bit more simple. So I have t plus 4d equals 70. Let's go t plus 15 times 4 equals 70. Oh, okay. Then I have t plus 60 equals 70. Then I have t equals 70 minus 60. T equals 10. Okay, so t is equal to 10. The last thing I would do is verify this. So I'm kind of running out of room. It's going to be a little bit tight for space, but we'll try it out. So we'll try putting this into both equations. Okay, so that means we have 5 times 10 plus 2 times 15 to give us 80. Let's try it out. That's 50 plus 30 equals 80. So 80 equals 80. Yep, let's try the other equation. The other equation was t plus 4d equals 70. That means 10 plus 4 times 15 equals 70. That's 10 plus 60. And that is 70 equals 70. Perfect. So that means The tulips cost $10 per bag, and my daffodils cost $15 a bag. And we have verified our work and everything. So on the next page is a check question. So this is on page 412. I suggest that you pause the video now, and then you can try this one on your own. Once you've tried it on your own, you can check the answers. So you can unpause it once you've tried this on your own. So we're going to start by creating a linear system to model the situation. We have two different kinds of footwear. We have running shoes, which are R, and we have hiking boots, which are H. They tell us that the store makes $25 profit off running shoes, or 25R, and they make $50 profit off of hiking boots, so 50H. They also told us that one afternoon the company sells 14 pairs of footwear, and they make $450 profit. So our two equations, the number of pairs sold, we have R plus H, sorry guys, this keeps unfocusing, equals 14. And for our total profit, we have 25R plus 50, H equals 450. So our new equations are R plus H equals 14 and 25R plus 50, H equals 450. For part B, they want us to solve this problem. So let's use that elimination method again. Now, it's probably easiest to work with the R terms. You could work with the H's, but they said look at the R terms. So our coefficients are 1 or R and 25. So in order to make them opposite integers, we need to take equation number 1 and multiply it by negative 25, okay? Because negative 25 will then make the other coefficient negative 25 and the other one positive 25. So let's multiply it by 25. Negative 25 equals R plus H equals 14. We end up with negative 25R minus 25H equals negative 350. Now let's add equation number 2 and equation number 3 that we just made together. We have 25R plus 50H equals 450, and negative 25R minus 25H equals negative 350. If we add those together, we end up with 25H equals 100. Divide both sides by 25, and H equals 4. Okay, so now in order to find our value of R, we put in H equals 4. Let's use equation number 1 because that one is a little bit more simple. So R plus 4 equals 14. That means R equals 14 minus 4, so R is equal to 10. So our solution is R is 10, H is 4. Let's verify that at the top of the next page and make sure that we did this properly. So what we think to be the correct answer is 10 pairs of running shoes and 4 pairs of hiking boots. Remember the running shoes we made $25 profit off of, so 10 times 25 is 250, and we made $50 profit off of those 4 pairs of hiking boots. That's $200. Add them together to get 450, and there are 14 pairs total. So that does match with our previous data. That means this is correct. So we have 10 pairs of running shoes and 4 pairs of hiking boots. So that's the end of today's lesson. I know this one was a rather long one, just wanted to make sure I had time to go through all the examples with you. I would now like you to stop the video and do the practice questions. Those are on page 413 all the way to 415. I know it looks like a lot of work, but it's really guided and it gets you through it pretty quickly. So please make sure that you finish those practice questions, check the answers using the answer keys on the Google Classroom. And of course, as always, email me if you have any concerns. Have a great rest of your day. Thanks.